Hello, welcome to another video. Today we are going to see something called activation functions, and for this we are learning about sigmoid and Relu. Activation functions are something that are useful when we are doing some layer to layer propagation. Let's say let's take the same mountain example, and when you start from here and needs to reach a location at one point, we can't expect that the whole mountain will be in a straight line. That will be wishful thinking. So, to depict or to imitate real time behavior, we'll add some sort of randomness to it. For this, we use activation functions. Bef- Before that, we need to know few things, and those are classification and regression. So there are several kinds of classification, but to make this simple, let me go with the simple one. There are two things: yes or no. These are binary choices. These can be represented as 0 or 1. So the end output or end goal should be yes or no. And the activation functions we are passing down between the calculations, these should be strictly between 0 and 1, so that the output isn't deviated. In regression we'll have a certain number for prediction. Let's say I'm selling a house or selling some product. I want to calculate some sort of value that I can sell it to. So in those cases, we are going to use regression. And to make this possible and add some non-linearity to the equation so that we won't be deviated from the real-time behavior, we'll use these activation functions. So just like in the last video, we have these gradient descent layers, right? And in these layers, at the end of it, we'll have a target. And to achieve the target, showing the real behavior, how real world works, we'll add this activation functions in between. So for now we'll take these two: sigmoid aims for the 0 and 1, and relu, the most commonly used activation function, which keeps things in between 0 and a positive value, so that we won't go to a negative value and there won't be a negative prediction. And for this we'll use these two. The formulas are 1 by 1 plus e power minus x. For sigmoid we use e power x because the limits are from 1 to 0 mathematically for e power minus x. And for relu we'll use the maximum of 0, and the values we have 0 comma x. So ever wondered what we see in a neural network 3D representation? We'll see the layers like this. but this is just the 3D representation, just to simplify things and make us understand what's the concept behind this. But the reality is this: we'll have different kinds of matrices, and we perform multiplication in between these and arrive at a single value based on the multiplication we got for different use cases. And these are done on GPUs, where GPUs effectively calculate these things. So this is the ground level knowledge we can knowledge we need to understand what are activation functions really. And most likely we use Relu, but if there is a strict use case to go to 0 comma, the value should be between 0 and 1, so that we can have an yes or no in place. But uh, for this we'll start with Relu in between these layers, and in the final layer we'll add sigmoid there, and take the estimate to keep it around 0 and 1. So this is the these are the things needed to learn about activation functions. So let's do some coding. For this we'll use numpy, and numpy provides different kinds of methods. You can refer to ChatGPT, or go through Geeks for Geeks or some other platform. And this is pretty straightforward, the formula. Let's start with a variable result, and we know we have this formula just right on top, 1 plus so for exponential we'll use np dot exp, and we have minus z, and the result will be np dot round of result comma 5. Sorry, we forgot something cool. That's 1 by 1 plus np dot exp minus z, and the return value will be np round as result comma 5. And for relu we'll just go through the max. That will be r dot sorry np dot max. Here people think that max will work, but actually the real method is the np dot maximum, which is used to do point to point measures. So traditional max just takes values between two comparisons. So here the max will be just 1, but np dot maximum does the position based check. Let's say we have two arrays, and I have two values here, and I want to check the maximum value at uh, each position. Then it will give us some sort of output like this, 2 comma 1, and this will be the final result. So instead of max, I'm going to use maximum now, and that will be 0 comma z. Let's run this. We got a wrong answer now. Let's check why this is happening right now. Let's go through the formula again, 1 by 1 plus. So let's add a bracket here, and done. So this is pretty much the traditional BODMAS thing that happened down here. So this is how you approach Sigmoid and Relu. You can go through the video given by Neat Code, and please like and subscribe. Thank you for watching. I want to make more videos on these topics, and I want to go beyond Neat Code GPT project. So please check out other videos too. Thank you for watching.